The concept that we will cover today is called inheritance. It is one of the most important concepts in object-oriented programming. Is that is inheritance. The idea is that it is the capability of one class to inherit properties from another class, and the technique of building new classes from the existing class is called inheritance. This is one of the methods of reusing the same class or same code multiple cases. Now the idea of inheritance, okay, is almost same as inheriting property. Okay, so you get like assume that you are inheriting your father's or parents property. Okay, so you get what they have. The difference is, in case of this inheritance, you can choose. You cannot choose to inherit your uh, other parents or other people's property, but in case of class you can choose which parent or which property you can want to inherit. The idea is that you have a base class, or which we also called super class. From that base class or from that super class, we will create new derived class or subclasses. So this is the basic idea in one diagram of inheritance. Okay, you see the arrow is actually going upwards. What does this mean? That means this class, okay, it may be A, B, C, or whatever it is. Okay, let's assume a name that we derived class or subclass, okay, will come from this arrow means is coming from this base class or super class. Okay, both actually are same. So sometimes you will say that in some cases it will be referred as a base class, in some cases it will be referred as a super class, but don't get confused. Same way, whenever you inherit a class, it will be called a derived class or subclass. Now base class is, it is the class whose properties are inherited by another class, so it is also called superclass, as I said. Now if any class can be a base class, okay, the class can have 1,000 line of code, or the class can have 1 line of code. The base class, okay, it doesn't matter that how many line of codes or how the structure look likes or the class looks like. Okay, if you can inherit a class, if it's a class, it can be inherited, and there is no rules that defines that which class can be base class. So any class can be base class and it can be inherited. Derived class, it is the class that inherit the properties from the base class or classes. So in that case, remember one thing, that there can be one base class or multiple base class. It is also called subclass, as I said. It inherits all the properties of the base class and can add additional features to the derived class. So that is the interesting part in case of inheritance. You can, if you inherit a class, you get everything they have. Okay, and you can add more to that. Okay, and that's where the C++ actually thrive. Okay, we'll see the examples, and very soon we will use this feature, the feature of inheritance, in most cases. Now what is the advantage? Okay, so there are various advantages, but these are the main three. First of all, code reusability. Using inheritance, we can reuse the same part of code again, and we can use it multiple cases, multiple, we don't have to write it. It's easy to implement in real world models. Okay, if you want to if you want to start a code, let's assume that I have written a code. That code is for I have written a code. That code is for a vehicle. That is, let's assume this is the code is for a car. Okay, now what you can do, okay, if you want to make a new program and you want to implement a cooler car, okay, your car will be look much more better. Okay, so what you can do, you don't have to start writing from the scratch. You can just inherit the code that I have written, and then you can make custom changes to that code. So that is one advantage. Okay, and it's very easy to implement and very transitive in nature. You can clearly see that what's happening in every step. Soon we will see some examples and it will be much more clear that what we are trying to do here. But in short, these are the three advantages. We can reuse the same code, so this is efficient. It's easy to implement the real world models. Okay, and it's very transitive in nature. Now the important thing is visibility modes, that in case of class, whenever we inherit a class, okay, we have to be careful about the access levels. So we know that there are three types of access level: private, public, and protected. So in case of accessibility, or the member of the base class, okay, or within the derived class, or the visibility of the class is actually private by default. Okay, so that means whatever we have learned so far about the private variables, they are applicable in case this case as well. And we will also see another case, that is if a variable is private, then if the variable is inherited, okay, how that actually works, and if the variable is protected and the public. So that's another huge discussion that we have to do. But first we'll learn the basic inheritance, and then we'll go into this. Okay, no, let's go to the next. So what is the difference between private and protected member? Because the public one, we know that if a variable is public, what does this mean? That it can be accessed from anywhere. Okay, so that is not our concern anymore. Our concern is with the new, this protected member. Okay, because we know if it's a private, that means it can only be accessed by the function, member functions of that same class, or the friend function. I haven't maybe discussed what is a friend function. Okay, I will discuss that as well. But we have discussed inline function, right? Okay. Now, as I was saying, so we know that there are three types of modifier: public, private, and protected. So public means it can be accessed by anyone. So that is uh, clear. Private means it only can be accessed by the member function of the same class. Then what is a protected? Okay, and how it actually changes. So private members can never be inherited. Okay, that's the one important thing you have to understand. Okay, private members can never be inherited. Okay, only the public and protected members can be inherited to the derived class. This is the difference between the private and protected members. So you see, this is now a confusion, that we cannot inherit the private members. So let's assume that if you're talking in terms of like property, like your parents, okay, they have their some personal properties, like name, okay, their ID, okay, and their some other features. Okay, so whenever you are inheriting the property, you cannot actually inherit their name, or you cannot take their other personal features. Okay, you can only take the properties. Now the problem is that if a class, okay, if a class, or if all the members of the class are private, okay, then how can we actually use inheritance? Because here it says that if private members, they can never be inherited. Okay, only protected members can be inherited. So this was actually a problem that occurred, and that's where the protected members help. Okay, so we'll discuss that as well. I just wanted to give you the idea here. So this is a chart that we use to keep in mind. So here we have the derived class visibility, and we have the base class visibility. So what does this mean? So we have these three cases. Okay, public derivation, private derivation, and protected derivation. So these are the way we can derive the variables. Now in case of private, okay, privates are not derived in the inherited class. So you see, this is the private variable, and what happens to the private variable. This is the protected variable, and what happens to the protected variable. This is public, and what happens to the public. So let's start with the simple one, public. So if you inherit a class, okay, if you inherit a class, I'm talking about this one. Whenever you inherit a class, we'll go into this direction. If the class is public, the variables are public, it remains public. Okay, if in the derived class, if the derivation is private, it remains private. If the derivation is protected, it remains protected. Okay, okay, secondly, if it was protected in the first place, okay, if it's a public derivation, it remains protected, that's okay. But if it's a private derivation, it changes to private. If it's a protected derivation, it changes to protected. Now, before going to this one, let's focus here again. It was public before, okay, and whenever the derivation is public, it remains public. Whenever the derivation is private, it remains private. Whenever the derivation is protected, it remains protected. So basically, we can say in case of public, okay, it doesn't change. Okay, if you use a public derivation, it remains public. If you use a private derivation, it remains private. If you remains a protected derivation, it remains protected. So this is easy to remember. In case of protected, okay, it also stays the same. In case of public derivation, it remains protected. In case of private derivation, it becomes private, and in case of protected derivation, it also remains protected. But in case of private variables, okay, in the public derivation you cannot inherit them. In case of private derivation, you are also not be able to inherit them, and same goes for protected as well. So here from this chart, what we can remember, that if a variable, okay, or base class have private members, that they will not be inherited in any case. Okay, if it is a protected, depending on how the derivation is done, okay, it will either be protected or private, but none of them will be public. Okay, if it's public, okay, if it's a, then we can change as however we want. So you don't have to memorize this now. Okay, we will, as we go on, as we practice, okay, it will be easy for you to remember. Now let's go on to the next one. Now this is called the accessibility chart. Okay, so this was the visibility modes, that whenever we're inheriting this, and this is the accessibility chart. Now this is to make things a little bit clear, because the last one is a bit confusing, and in case you didn't understand this one, let's look at this one. So here what we're trying to do, we are trying to accessibility of a member by various objects. So like if you have created a class, let's assume the class is car. Okay, and from there you inherited another class that is called, let's assume that uh, red car. Okay, so you have created another class red car. Now how can we access the variables? Is it possible to access all the variables? Okay, and so on. So let's assume that the class that you have created, the members were private, all the members were private. Okay, now can you access from the same class? The answer is yes. Okay, can you access from the derived class? The answer is no. Access from the objects outside the class? The answer is no. So if you declare a class, or if you derive from a class, okay, that is private, the members are private, okay, in that case we can access, but from own class, but we cannot access from derived class or objects from outside the class. Same goes for public. Okay, if it's a public, that it can be accessed by everyone. Okay, doesn't matter how you want to do it, you can be accessed by everyone. So this is easy to remember. And the third one is protected. So if it's a protected, okay, again it can be accessed in all the cases, only not by outside the class. So if to interpret this chart, okay, we first focus here. If it's public, that anyone can access it. If it's protected, okay, anyone can access it apart from this objects outside the class. Okay, so objects that is outside the class, they will not be able to access it. And if it's private, okay, no one can access it apart from this one, the objects from the same class. So this one is normally the old concept that we know, that whenever we declare a class, and if the members of the class is private, only members of the own class can access it. Okay, that's it. So this is the old case we know, and this is the public we know. That the protected will just give a different idea, that you can access it from the own class, you can access it from the derived class. Now all this might be a little bit overwhelming, okay, but whenever you are starting the example, you can go through the video again and see one by one. It will clearly it will be much more clear. Now I'm going to stop here. Now there are total 5 types of inheritance that we can use. One is called single inheritance, okay, that where you inherit from one parent. One is called multiple inheritance, when you inherit from multiple sources. Okay, one is called hierarchical inheritance, one is called multi-level inheritance, and finally the last one is hybrid inheritance. So depending on the situation, what we want to do, we will have to use one of these 5. In most cases for now, we will use single inheritance. So let's start with the first one, single inheritance. It means that you'll have a base class, that is X, and you have a derived class that is Y. So derivation of a class from only one base class is called single inheritance. This is the simplest of all inheritance. Okay, now what will be the syntax if you want to use a single inheritance? So you will have a derived class. Okay, so let's assume this is our derived class in red. Okay, what will be the visibility mode? Okay, and the name of the base class. So let's assume the example I was talking about, that is car. Let's assume that we want to, I have created already a class that is called vehicle, and I have asked you in the question that inherit this vehicle class and do something else, or add this function. Okay, let's assume I haven't implemented the function of door. So I have asked you that, okay, so inherit my class and add door, or add a speed or something. Okay, so what you will do first, you will need the name of base class. So that is in the blue, you see. So vehicle is our base class. What is the visibility mode? Okay, that is public, so we are using public. And then what is our derived class? The new name is automobile. So the in short, class automobile, that is our new class, that is publicly derived from vehicle class. And then we will go to the details of the code, but this is the basic syntax. Next one is called multiple inheritance. That means you will inherit from two classes, X and Y. So let's read the slide, just a minute. Now, as you can see in the multiple inheritance, okay, we can derive from two or more classes. So in this example, we have a new class that is class Z, okay, and we are deriving class Z, okay, from class X and class Y. So the syntax will also be almost same. There's no difference. So here again, we have the derived class that we want to derive, and visibility mode of both classes. Okay, so if like assume the child class, so we are creating a new child and we have these two classes, and in both cases you have to separately write the visibility mode. If you are still confused about what is the visibility mode or what is the role of visibility mode, don't worry, we will discuss it in details in the example in the next class. Okay, but for now let's get with the types of inheritance. So again, you will write the new name. So let's assume I have told you that instead of using child, use a class named ABC. Okay, so you write class ABC. Okay, depending on the name I have given you. Okay, or you can use your own name. Then public father, public mother. Okay, it can have another class, public or private. Let's assume that the new class is private, and private less son, it can have another class. Okay, then we have this hierarchical inheritance, that is derivation of several classes from single base class. So that is called hierarchical inheritance. So we are basically covering all the possible combination. Previously we have used example of that, what if we can two class, from two base classes we can create a new class. Okay, in this one it's the opposite, from one class we can create multiple classes as well. So the syntax is almost same. The derived class 1 visibility mode base class, derived class 2 visibility mode base class. That is double syntax, that's it. So here as you can see, you just have to write the single case two times, so you can use the basic syntax. So this is where we will stop today.